Hello, everyone. I'm Alessandro, Head of Product at the Algorand Foundation, and I'm here with Rob. Hi, Rob.
Hey, Alessandro. So I'm Rob Moore. I'm the co-founder and chief technology officer of MakerX, which is the delivery partner working with Algorand Foundation on the delivery of AlgoKit.
Exactly. So Rob and I are working hand in hand together to bring you things like the CLI, AlgoKit utils, and Algorand Python. And we're here to talk to you about what's happened with Python and what we have worked from Python's release. So, Rob, in your opinion, why was it extremely important for us to go down the rabbit hole of semantic compatibility? And also, what is semantic compatibility?
Yeah, good question. It's certainly not something that I guess is easy, but there's it's a very deliberate decision that we made, and there's a number of advantages for it. But I guess firstly, sure, what is it? The idea behind it is that you could take a high level language, in this case Python, and someone that knows Python but has never interacted with Algorand can write Python code that is what we call semantically and syntactically valid Python. So the syntax of it is the same normal Python syntax. We haven't added any extra keywords or there's no weird kind of different order that you put things in that isn't actually valid. And then semantic correctness means that when you write that Python code to express some sort of logic, when that same logic runs on the AVM after compilation, that the behavior on the AVM exactly matches the behavior if you executed that using a normal Python interpreter. And why would we do that? Because as I said, it is extra work. Well, there's a number of reasons. So firstly, we wanted to have an experience that people that had never used Algorand before could kind of dive into this and start typing code and not have any surprises. So they would be able to get started really quickly, and they would be able to write code that was actually correct for what they wanted to do without having to do a lot of weird learning of what this code is meant to do, or having these sort of surprising moments. And certainly if you think about it, when you're writing smart contracts, it's really important that the smart contract code is correct. Quite often smart contracts end up protecting items of value, and quite often the best practice would be that you deploy the smart contract code and make it immutable so that it can't be updated, which means you kind of need to get it correct first go. So all of these reasons mean that we want to follow the principle of least surprise. When you write the code, it does what you would think it would do from writing that code. But there's another reason why we wanted to do this semantic compatibility, and it basically allows us to create a automated testing layer that actually runs the code in the Python interpreter. And then you can write assertions in a normal Python unit testing framework. And you can also do breakpoint line by line debugging of your smart contract code within the Python interpreter. And the reason why we want to do this is it will enable users or developers to write automated test code that executes in milliseconds rather than multiple seconds, and gives them a feedback loop that is really, really, really quick and slick. And we know from experience that the smaller you can make the feedback loop, the better the developer cycle is, the easier it is to find problems in the code and solve them. And then the other thing that it does is, because you've reduced the amount of time it takes to execute that test by an order of magnitude compared to actually sending the code to the AVM and constructing a transaction, sending it, it means that we can do tests that run, I guess, an order of magnitude more kind of test cases. So we can start doing things like property-based testing, combinatorial testing, maybe even model-based testing, and do much more rigorous testing that happens in memory in process in millisecond time, maybe hundreds or thousands of tests for an individual, say, smart contract method, as opposed to do the same thing against the AVM, you'd be waiting, potentially hours or many tens of minutes for this test suite to run, which again goes against best practice sort of, developer experience of wanting to have fast feedback cycles. So this is like a really powerful concept that we, haven't seen out there elsewhere in the industry, and certainly in Algorand before we implement this feature, which we're currently working on.
Yeah, exactly. And the thing is, if we would have strayed away from the semantic compatibility, all of a sudden, all of the testing tools and everything should have had to be developed custom. Now with this, you can use PyTest, and that is the beauty of it.
Yeah, exactly. And now we would always advocate for a sort of a structured automated testing approach where you'd use different types of tests for different scenarios. And we're not saying that because we implement this and it's faster, that you would use this in lieu of actually testing against the AVM. Like clearly from a risk perspective, you want to be doing that anyway. So what we're saying though is that this opens up a whole new range of styles of testing that you can augment that with and improve reduce the risk of your smart contract and improve the sort of testability of it. And yeah, it's a really powerful kind of capability, and I'm quite excited to see what people end up doing with it.
Yeah, it's fun. I'm looking forward to. And for those of you at home that are listening in, you can find the branches in the Puya repo. We're building it in the open, so take a look at it. Comment, contribute if you have any ideas or want to shape things. We're always open to contributions. So just we'll see you on GitHub. Let's say it.
Yeah, definitely. And actually, it's quite cool seeing the way that it's evolving, because we're doing things like, say, there's a particular opcode that we have a stub abstraction for in Algorand Python, like op.mulw or something like that. What we do is we have the implementation that runs for that opcode when it's run in Python against the Python interpreter. And then we've got obviously the implementation of calling that opcode on the AVM, and the automated testing that we're doing on the Algorand Python test runner basically runs both of those two things with a series of parameterized kind of values and checks that they're both the same. So as the AVM evolves, we will have a great deal of confidence that the test runner has the same behavior as the underlying AVM. So there's a lot of effort, a lot of engineering effort and rigor being put into making sure that this feature is quite robust.
Yeah, I cannot wait for people to actually play around with it. And speaking of things that are under the OP namespace, but we're working towards improving and giving it a better API interface, how's the work on BoxStorage, which some of you may know that is coming? We're working on it, and developers at Cypher should have it in their hands ready.
Yeah, definitely. So look, BoxStorage is kind of, I think, something we did want to try to get in 1.0, but it's just one of those things we ran out of time for, right? And so since we sort of launched 1.0 and then in the sort of post release kind of fixing and feedback loops and all that sort of thing, we've started working on getting a much nicer BoxStorage API. So for those of you that had done like Beaker smart contracts, there were some really nice BoxStorage abstractions in there, like a box map as an example. And we're bringing a similar kind of experience, but even more powerful to Algorand Python. As you said, that one will be ready for Decipher. Interestingly, we discovered, because in parallel, we're also working on kind of a bit of a spoiler alert, adding a front end for a different language, as well as Python, to the Poya compiler architecture. And so we're doing the design work for that right now. And we were looking at BoxStorage API, and we kind of realized that, the sort of layers that we have in the Poya compiler, some of the Python stuff at the front kind of bled through a little bit, which kind of makes sense. Like, you kind of design something for other uses, but until you have those other uses kind of, as a more tangible thing, you kind of realize, oh, some of our abstractions weren't quite right. So the BoxStorage stuff kind of helped us highlight some of that. And what we're doing is implementing that, and also implementing some changes to make it easier to add other front ends. And then what we're going to end up doing is creating documentation for how people can add other front end languages. So whilst we'll have some official ones, the community will be able to contribute their own front end languages if they want to as well.
Exactly. I cannot wait for that learning path and documentation series to come out, because I want to see people harness the power of the Poya compiler and bring their own favorite language as a smart contract writing programming language on Algorand. And speaking of another advancement on the Python side of things, we are working on, at the moment, we rely upon localnet and the AVM to precompile and compile your contracts from teal to bytecode. Yep. And we are working on removing that hard dependency. How's that going?
Definitely. Yeah, so one of the other features that was in BCAR was this concept of pre-compilation. This is really useful for situations like, for instance, if you're doing a smart contract that vends other contracts. So you make some sort of call to it, it will then take some bytecode for a different smart contract and create it. Like a child contract maybe is the right analogy for it. Now, in order to do that smart contract needs to have the AVM bytecode, because there's certainly no way on the AVM of taking teal code and compiling it. That's way too, intensive an operation, and certainly just not a capability. So you need to have AVM bytecode. Now, in BCAR, the way that was implemented was that when you had a precompile call, it would go off, find an AlgoD instance, which I think it was probably just hard coded to localnet or something like that. And it would send the teal code, get it converted to bytecode, and then pop it in. Now, that's fine. It's all well and good, but it's a little bit weird building a compiler that has to make out of process calls to get bytecode. Like it kind of doesn't really make sense. And so as we were implementing the precompile support, which by the way is in the final stages of draft, I think it's pretty close to being released. So that'll definitely be there for Decipher, and in fact probably earlier than that. Anyway, while we were implementing that, we realized that when we looked at the implementation in the core Algorand code of how it actually takes teal code and turns it into bytecode, that the implementation is reasonably straightforward. I mean, it kind of makes sense. AVM as or teal as a language is very simple. And we realized that we actually already had the building blocks to be able to easily emit the bytecode, because we already have in the Poya compiler architecture like an abstract syntax tree to represent teal, because we needed that anyway to do certain compiler optimizations before emitting the actual teal code. And so going from an abstract syntax tree that we already had to the bytecode was really easy, because the langspec file that we generate by combining the langspec file that exists in core Algorand, and we also read the Go code and pull out certain extra metadata that's not in the langspec, and we generate this kind of custom langspec, but it's fully generated from the source Algorand code. We could pull the bytecodes out of that. So our actual implementation is really small. Like it took our engineer like 2 days to do, and we've written a lot of automated tests to make sure that the bytes that get generated from our compilation exactly match the bytes that get generated when you send it to AlgoD to compile. So that's really exciting. Like it was cool to see that come together very quickly. And now like the Poya compiler can take whatever the high level language is and go all the way to AVM bytecode, all offline just within the compiler itself. So it's quite powerful. And again, really exciting.
This opens up to many opportunities, and I cannot wait to see what our developers do with it. Switching a bit gears and going back to the first effort that we did, and the one that started it all,
CLI.
the CLI. It's been a while. What is it? I think we released V1 in March 29, but I think the first time we spoke about it and the first time actually the CLI idea was born stems back to September in a meeting room in Singapore. You, Matt, John, and myself, and that was what kickstarted everything.
Yeah, I remember it was really cool. We put a whole heap of stuff on the whiteboard. From memory, we managed to get John talking to us about cryptography, and he was really in his element. He loves that stuff, right?
Yeah, you see the sparkle in his eye every time
Yeah,
he talks
yeah.
crypto.
He regresses back to his childhood when he's talking about cryptography.
Pretty much. But AlgoKit is 1 and something years old, and we have had heaps and bounds of feedbacks and heaps and bounds of updates, some of
Yeah.
which were a bit more difficult to tackle. We know that our developer community is widespread. We have developers in every continent, probably in every country. We don't know that. We don't track those things. But we have noticed that there were quite some difficulties going with Docker, and some developers struggle with it. My suggestion as a former developer is choose some glass. Docker is a necessary evil at the moment, but Docker is something that in your career you will encounter, and virtualization saves you a lot of pains down the road. But in the meantime, we have found a way around it. And what is it?
Yeah. So it was actually quite brilliant, I think, and I can safely say that because I actually had nothing to do with this idea, so I'm not big upping myself. And I actually had no idea that the team were even going to do this. Like, I think someone just came up with the idea, spiked it out, and realized it was possible. So what they're doing is they're using GitHub code spaces, which, if anyone's not aware, is a feature within GitHub where you can actually spin up essentially a set of containers that GitHub's running for you, like essentially mount ports from that on your computer as local ports. And what we realized was, you can do that, run AlgoD and Indexer and KMD and all of that on a code space, and then just map the ports that get produced from that on your local machine in the same ports as they would be if you were running on Docker locally on your machine. And we've tried that out, and it works. It's brilliant. So it means that if you're on a computer that, maybe your internet access isn't as good and you can't download all of the, dependencies, particularly if you're on like maybe a Windows version that doesn't have WSL2 installed and you have to download all of that, like that's quite significant. It's certainly one of the complaints we've heard. Or you just don't want to use Docker or whatever it might be, then now there's an option that will be released soon, because it's not in there yet, is it?
Nope, it's not in there yet. It should be in. I think we are in the closing stages. We're finishing it up.
Nice.
And this idea started. We were reworking the templates for the Init Wizard V2, so the new project initialization process that we have with version 2 of AlgoKit. And while working on the templates, we were thinking, hey, let's make it actually an official template that you can use GitHub code spaces with. So you simply click use as template on the repo itself, and it stems up an AlgoKit project in code spaces. And we realized that we were pretty much there to have localnet running. So it started from there, and it's
cool when those serendipitous things happen. Yeah. And actually, speaking of version 2, so I was just looking at the releases. We're up to 2.0.6 now on the CLI, but on March 27 this year, that's when 2.0 of the AlgoKit CLI was released. And yeah, the two big things added was the Algorand Python compiler was added, so you can go AlgoKit compile Python, without having to install that separately. But then the other one was this huge thing, this new capability, AlgoKit Project. And because what we realized is we had some stuff, some commands in there that were just general commands like run localnet or run the Go command line or whatever it might be. And then some of the commands we had would actually operate on your current like file system on a project that was where you were. So you could run like AlgoKit deploy and that sort of thing. And so what we realized was that there's quite a powerful concept there around AlgoKit understanding a project and being able to do things with a project using standard command names like AlgoKit project run or deploy or whatever it might be, and abstract away the underlying whatever the semantics are. So npm if you're running a node project, or the Pi project and all of that sort of stuff, poetry. So yeah, there's this kind of powerful concept has now been added, and so AlgoKit is now actually a project system that works on mono repos, including things like linking from, say, a smart contract project or multiple smart contract projects into a front end to generate a typed client and put it in based on convention in these kind of loosely coupled config files that are in each project. And all of the AlgoKit init templates kind of support this now. And you can opt out of this. You can do a standalone project by passing -- standalone when you do an AlgoKit init, but by default, it'll kind of add all of this functionality for you. So it just makes things a bit simpler, a bit more consistent and easy to use, basically, when you're dealing with a project.
Yeah, this started as because the NFT voting tool smart contract has multiple front ends. People may or may not know of it, but the buildable Finale voting platform is the same smart contract as the NFT voting tool, which is the same smart contract as the Xcode.
Yeah, that's right.
And so, as to keep best practices and keep the smart contract there, and with the audit itself, we've added multiple front ends to the same project. So command orchestration, command orchestration all of a sudden became a must, because you cannot say, "Hey, let's deploy," because you're going to deploy on 4 different things. And with this, we can configure it and namespace it. So we can say deploy Xcode, deploy NFT, deploy Finale. So yeah, this is something that's really fun. And also, we have noticed that some of the people installing AlgoKit would have issues sometimes with Python versions and all that. And we have got you covered. Something that is coming. We are at the moment. It's taking a bit longer than we wished for, and it's a whole saga. We could write a book around it, but the thing is
the intricacies of code signing certificates.
Exactly, code signing certificates, and dealing with companies that will allow you to issue code signing certificates.
Yeah.
But we have a version of AlgoKit CLI coming as a binary. So all of a sudden, you won't have any dependency issues when installing AlgoKit and working with AlgoKit.
Yeah, exactly. And a cross-platform binary at that. So we're building it for Windows, Mac, both
Intel and ARM.
Thank you. Yeah, Intel and ARM, and also Linux.
Yeah.
And we're also releasing it on these binaries on the package managers that you expect on those operating systems as well.
Exactly.
So it'll be a really nice experience. It's kind of that extra kind of like polish, I guess, that you see on all the really prominent CLIs. So like if you go to Microsoft Azure or AWS CLIs, they do this same thing. But so now we're up at that echelon of having native cross-platform binaries that are code signed and released in the proper app stores and all that sort of thing. It's really really exciting.
This is fun. Then one thing that has been stealth launched, aka it's out, but we have never talked about, and I think it's high and night time that it shines. It's something that is, I would call, one of your magnum opus. It's like it's a work of art, and it's the subscriber library. Can you tell us a bit more about it?
Yeah. I don't even know where to start.
We could start. What was it? I think October last year that we
Well,
were
for me, it
thinking.
started like 6 months before that because I had this vision quite a while back when I was sort of looking at the way that indexing happens. You've obviously got the Algorand indexer, which is, I mean, it's awesome. Like it's pretty powerful, but we know that it's hard to run it, like, and it takes a lot of compute and file system storage and all that sort of thing. And there's obviously a sync delay sometimes and all of that. And so, and the other thing, of course, being that anyone building a D app, like if you're relying on that there as your main source of data, like you're generating all this load on this central service, like it's not very decentralized, and you lose a lot of control, right?
And it's
Now,
operationally very expensive.
yeah, if you're running your own, exactly, then it's very expensive. And the other thing, of course, is that indexes like the entire chain.
Yeah.
And if you're doing a D app, you need like this tiny slice of it, right? And so the idea that I had was, and sorry, and then naturally there's Conduit, which is like it's a very very fancy indexing solution, very robust. It's built by the core Algorand team, and it's the technology behind Indexer. But it's not necessarily a very friendly thing to develop against. And certainly a lot of what I wanted to do in my indexing needs, and the main driver of this actually was the Data History Museum, which, if anyone's not aware of it, we automatically mint verifiably authentic digital historical artifacts of events as they occur in real time. So specifically at the moment, earthquakes and solar flares. We encode a lot of metadata in that. So we have like the geolocation of the earthquake or the magnitude and the peak flux value of the solar flare, as well as the media, like the video of the solar flare, for instance. Very cool. And so I've got this project there where if you wanted to build an index on that data, you want to like do it in sort of real time, but you don't want to rely on indexer because it's slow. You kind of want to have a database sitting there with all that data, but you want it to be reliable. You don't really want to kind of like poll, like, I mean, you can poll indexer every now and then in the background, but it just you're not going to get these sort of real-time updates. And so,
And
long
at the
story
beginning
short,
of it, we were thinking of putting a GraphQL interface on top of Indexer as a solution. But then we realized that you'll still have to run an indexer. So it's, yes, we're
yeah,
democratizing access to the data, making it easier, but the
exactly.
core chunk of the problem and core pain is that you're still running indexer. So yeah, we had to come up with a
Exactly.
different way.
Exactly. And we looked at subquery, which is very cool, but there's a number of issues like and actually the same issue as well with Conduit is that if you want to index something that's been running for a while, like Data History Museum's been running for like, I don't know, 2.5 years, or I don't know, whatever it is, you kind of have to start, from the beginning of the chain almost, and spend days and days and days building up your index. And it really felt to me like I don't know, a frustrating or kludgy way of doing it. And so the original kind of idea that I had that I spiked out 6 months before we started talking about the subscriber was the idea of basically building a like, in this case, Node.js. I mean, it doesn't have to be Node, but a language that is familiar, right? And at the time, like, I've been writing a lot of TypeScript. So I wrote it in TypeScript, and I had this concept of a fast catch up using Indexer, but then when you're at the tip of the chain, using AlgoD and subscribing to the raw blocks as they came through, and then being able to define a filter that is specified in a way that's kind of, I guess, abstracted. So you could do things like give me all transactions that were created by this user account, and they're of type ACFG, asset config.
Yeah.
And you know, that could just be a plain object. And so you can have this really nice interface that is just like an object, and, you know, a couple of other configurations. And you can make the thing reliable by using watermarking. And the nice thing about the Algorand blockchain is you've got this monotonically increasing block number. So you can watermark based on that. And as long as you're persisting the watermark in the same transaction as you're persisting any of the data that you've just subscribed to in an ACID transaction, then you've got something that is rock solid, reliable, and will only have in your database the stuff that you're interested in. And so essentially, we kind of realized that this solution could work. And so we built it out. We've, as you said, we've released it as a 1.0 release. And it's got this really, I guess, powerful set of features in it to do things like, you know, subscriptions, indexing, you know, all of these sorts of things. And can do fast catch up with an indexer and or just using AlgoD. It's got the ability to run multiple filters. It's got this really nice sort of event emitter style API. It's really, really terse, easy to use and understand code. And some of the more recent stuff that we've added that's quite powerful includes balance change detection. Now, the interesting thing is the number of transactions that can change a balance for either algos or an asset are quite surprising.
Yeah.
Especially if you're kind of new to the blockchain, you easily miss some. And so we've got this full capability in there to detect any balance changes and give you that metadata, so you don't have to go and calculate it yourself. And it includes doing things like, you know, understanding things like asset closeouts and all of that sort of thing. And you can also subscribe to balance changes. So you can issue a subscription and say, tell me whenever the balance changes on this account. And you will only get notified for transactions that cause that to happen.
And this is something that I'm clearly in love with this library, because in my free time, I'm pretty much an on-chain detective. I like to simply dig through transactions and see where they go, and I don't know, it's simply fun. And this library just simply, I can set it up saying, hey, monitor my address and ping me every time I receive something. And the amount of flexibility something like this gives you as to bridging things that happen on chain to real life or Web 2, it's stunning. You can have, I don't know, your Roomba start whenever someone buys your NFT.
Nice.
Or something like that.
Absolutely.
It can be it's as flexible as you want, and it's astonishing.
Yeah, no, definitely. I think it's really cool. The thing that I've actually got a draft pull request up for something that's a bit of a crazy feature that I've not seen anywhere else, which is this concept of dynamic filters. So the example for this would be something like, I want to subscribe to all asset config events so that I can pick up any creations or updates of the asset, say that the Data History Museum is creating. But then once I've done that, I want to then subscribe to any balance changes on any of the of those assets. And you don't know ahead of time what the asset IDs are that you need to subscribe to. And you want to make sure that you don't miss any. So you can't have some sort of process that in the background you need to update some other database because you might miss blocks. So we, in a transactionally consistent way, now have the ability, will soon have the ability, because it's draft, to create filters based on the other things that you're subscribing to, and then persist those dynamic filters in the same ACID transaction as everything else. So you've got
It's
this like robust
filter creation.
Yeah, exactly. And I've never seen that anywhere else, but it's a super powerful feature that I'm really excited about. It was quite hard to implement, but yeah, it's super cool.
I mean, this is incredible, and we cannot say what is it, but the subscriber library that we're talking about is it's the beating heart of something that we will announce at Decipher, and we can simply say that the internal name is the developer's best friend, and the heart and soul of the developer's best friend is the subscriber library. I cannot wait for you guys to try it out at Decipher, to be honest. And yeah, you're coming to Decipher, right? We have a talk together.
Yeah, definitely. Yeah. So looking forward to that. And if anyone wants to try to find me, I'll be around. So yeah, very exciting.
Exactly. Don't be shy. As you hopefully have seen, we're fun people. We're chill. You can come up to us, say hi. If you have any questions, ideas on what you want to see on AlgoKit in the future, or want to pitch us how the crazy way you're using AlgoKit, just come say hi.
Yeah.
Well, I'd say this is it for this episode. Next month we'll do an update on what we have talked about here and the new things we're working on. So thanks a lot, Rob, for joining. It's been a blast.
Thank you. It's fun.
And have a good day, everyone. Peace.